Welcome to my lesson over trigonometry. So we have here our trigonometric ratios. And so we're starting off with the fact that each of the functions is going to represent a fraction. And you can write this fraction using the sides of your triangle. Before you write the fraction, you first need to figure out which sides of the triangle you need to use. So here we have our three trig functions. We have our sine, which is going to be the ratio of the leg opposite of your angle divided by the hypotenuse. Then we have our cosine, which is going to be the ratio of the leg adjacent to your angle, so next to the angle, divided by the hypotenuse. And then lastly, we have our tangent, is going to be the ratio of the leg opposite that angle, divided by the adjacent leg to that angle. Okay, so looking at this triangle here on the left, we are going to go over just how you can identify those side lengths, your opposite, hypotenuse, and adjacent. So starting off, I'm going to figure out which angle I'm looking at. And so for this one, I'm going to go ahead and say we're going to look at this angle A up top. And so I'm going to call that theta. So once I have identified my angle, a key trick that I use is I circle it. And so the opposite side, once you've circled it, should be the side that you don't touch. And so here my lowercase a is the only side not touching. And so I'm going to label that as my opposite. Then for your hypotenuse, the longest side of your triangle, identify your right angle. So here it's going to be that capital C. And so the side that's not touching your right angle should be your hypotenuse. So my lowercase c. And then lastly, you have your adjacent, which just once again means next to. While technically you do have two sides next to your angle, the hypotenuse is one of them. The other will be your adjacent. So I can label that lowercase b as my adjacent. So now let's look here at question number 1. They say give each trigonometric ratio as a fraction in simplest form. Okay, so here if I look, we have sine of angle A, cosine of A, tangent of A. Then over here we've got sine of B, cosine of B, and tangent of B. So our answers are going to switch up, but we're going to use the same triangle. And I'm going to start off with my angle A's first. And we are going to identify our opposite, hypotenuse, and adjacent from that angle. So looking here, we have our angle A. I'm going to circle that. My opposite is that 10. My hypotenuse is that 25, okay, because it doesn't touch my right angle. And then my adjacent is that 5 root 21. All right, so let's start off with our sine of that angle A. So sine is going to be your opposite, so we'll have 10 divided by your hypotenuse, 25. As they mentioned, we should have our fraction written in simplest form. So here, when I have that 10 over 25, I can simplify to 2/5. And so that's what I'm going to write on this first line here for my sine of angle A. All right, so now let's look at our cosine of angle A. We have, for cosine, we're going to be dealing with my adjacent. So that would be that 5 root 21 over my hypotenuse, which is that 25 again. So remember, when it comes to simplifying your fraction with the radical and the numerator, we're just focusing on those outside numbers, so that 5 over 25 will reduce down to 1/5. And so we'll have root 21 over 5. And then for our angle A, we're going to move into our last one is tangent. And so we'll have our opposite, 10, over our adjacent, 5 root 21. Now remember here, we cannot have a radical in our denominator, so we are going to rationalize by multiplying by that root 21 to the numerator and denominator. Okay, so when we do that, we are going to get 10 root 21 over, and we'll have that 5 times 21. So the reason why I didn't multiply them yet is just because I'm looking at my smaller numbers, and I can see here that that 10 and that 5 can reduce. So here 5 will go into 10 2 times. And so my final answer is going to be 2 root 21 over 21. And so those are going to be my answers for the angle A. Now let's come back to this picture, and we are going to look at using our angle B. So here I'm going to start by circling angle B. Noticing that my hypotenuse does not change. We will still have that 25 as my hypotenuse. But my opposite and my adjacent are going to switch. And so that is going to change up some of my answers. Okay, so starting off with our sine for angle B, we have our opposite. So looking at blue, we got that 5 root 21 divided by my hypotenuse of 25. Now that might look a little familiar because we did see that for our cosine of angle A. And so that will reduce to that same root 21 over 5. Then moving on to my cosine of angle B, we will have our adjacent, which is now that 10, over my hypotenuse of 25. So 10 over 25 will reduce to that same 2/5 that we got for our sine of angle A. Okay, so if you hadn't noticed yet, our sine of angle A should be the same as my cosine of angle B, and my cosine of angle A should be the same as my sine of angle B. Now, with our tangents, they will be different, okay, but they're going to be very similar. So with tangent of angle B, we would have my opposite, which we labeled as that 5 root 21, divided by my adjacent, which is that 10. Okay, so initially we are starting out with the same, but when we reduce it, will kind of look different. So here that 5 over 10 will reduce, and when we reduce it, we are going to get root 21 over 2. All right, so that's how you do those problems. Now let's look at this next section here, which we have, make sure your calculator is in degree mode. Okay, nice and bold. We want to make sure that that is happening. It's very, very important. And so I like to use a little rhyme to help me remember. We've got rad, R-A-D, is going to be bad. And then we have D-E-G is what you want to see. Okay, and so in class, since I'm unable to show you in this video, I will show you how you can plug that into a calculator and where you want to check for that rad or degree to make sure you're in the correct mode. Now, looking in this section here, I also am going to give you a mnemonic device to help you remember your sine, cosine, and tangent ratios. So I like to use, we've got SOHCAHTOA. Okay, and so the way it works is you have that SO, S-O-H, is going to stand for your sine of theta is equal to your opposite over your hypotenuse. Then when we get to the CA, you have cosine of theta is your adjacent over your hypotenuse. And then lastly, you get to that TOA, tangent of theta is equal to my opposite over adjacent. All right, so we have a few steps in this next section that I'm giving you. Okay, you obviously don't have to use them, but they are an option. And so I'm going to read through them and then we'll use them to solve the 6 problems down below. So we have steps to follow to solve for your side lengths. We got step 1 is mark your angle for what you're looking at. Step 2, label your sides in relation to that angle, opposite, adjacent, and hypotenuse. Step 3 is to write an equation using your angle, sides, and the trig function. Step 4 is solve for the side length. And step 5, round as directed if necessary. So to clarify for those of you that might be watching this video and are not in my class, we do not allow them to use calculators. And so I'm going to leave all of my answers in calculator ready form. And then for those of you that are allowed to use a calculator, you would just plug in what I give you as my answer into the calculator to get your final answer. All right, we're going to see pretty much the same steps on the next side where we have our steps to follow to solve for angle measures. Step 1, mark your angle you're looking for. Step 2, label your sides in relation to the angle, opposite, adjacent, and hypotenuse. Step 3, write an equation using your angle, sides, and trig function. Step 4, solve for the angle, theta. And step 5, round as directed if necessary. So, like I said, I'll walk you through these steps when we're working through our problem. So we have here, write the trig ratio equation and the calculator ready equation, find x or theta. All right, so following my steps, I'm going to start off with my step 1 is circling my angle, labeling my angle, okay? And then I'm going to label step 2, my opposite, hypotenuse, and adjacent. So my opposite side it doesn't touch. My hypotenuse, which is across from my right angle, and then my adjacent. For step 3, to write your equation, you have to determine which trig function you're going to use. So the key thing is going to be the fact that here I have a side length for my opposite and for my hypotenuse. So these are going to be the 2 sides I need to focus on finding a trig function that we'll use. And so that's going to be my sine. So we'll have sine of our theta is equal to, and we'll have our opposite, 15, over my hypotenuse, 24. Now, the key thing is when you are solving for your angle, what you do is you are going to use inverse trigonometry, which will allow you to switch those two. We'll switch our angle with our ratio. And so we are going to get inverse sine, and we'll have that 15 over 24 is equal to my theta. Now, for my kids, once again, since y'all do not get to use a calculator, key thing here is making sure that your fraction cannot be simplified. Okay, so here, this one can be, and so we are going to rewrite this with a simplified fraction inside my parentheses because everything should be simplified. So that 15 over 24, both numbers are divisible by 3. And so my final answer here is going to be that inverse sine of 5/8 is equal to my theta. All right, so here my final answer, what you would need to plug in, this would be my calculator ready form, is going to be this answer here. And the key thing that you would also need to show me would be the initial trig ratio equation. Okay, so these two things, first one and last one. Now let's look at number 2. Okay, so here for number 2, we're going to start off with marking our angle. We have that 21 degrees. So my opposite, my hypotenuse, and my adjacent. Then to determine my trig function, I'm going to look at the two sides I have something for. We have that x. Obviously, we want to use that. That's what I'm trying to find. And then we have our hypotenuse length. So my a and h is going to tell me that I'm going to use cosine of my angle, 21 degrees, is equal to my adjacent x over 26, my hypotenuse. Okay, so this is my initial trig ratio equation. Then to solve for x, I'm looking at that fraction. And so I need to isolate that variable by moving that 26 to the other side. So I'll use my inverse operation to multiply that, and we'll have that my x will be equal to 26 times cosine of 21 degrees. Okay, to clarify, what we're doing here is we're multiplying that 26 to both sides so that we can cancel out with this fraction. And now you have your answer. So x is equal to 26 cosine of 21 degrees. Moving into number 3, we have, I'm going to mark my angle, which will be that 28 degrees. Labeling my opposite, my hypotenuse, and my adjacent. Highlighting those two key sides I actually have something on. I can see here I'm using my opposite and hypotenuse. So that will tell me to use sine of my theta, 28 degrees, is equal to the opposite, x, over my hypotenuse, 19. So once again here, since my x is in the numerator, to move that 19 to the other side, I'm using that inverse operation of multiplying. And so here I'm going to get that x is equal to 19 times that sine of 28 degrees. Moving into number 4. Okay, I'm going to mark my angle. I have that 72 degrees. My opposite across from that is 25. My hypotenuse is going to be the blank side. And then my adjacent is that x. So the two sides that I have something labeled with are going to be my opposite and my adjacent, which means I should be using tangent of that 72 degrees is equal to my opposite, 25, over my adjacent, x. All right, so unlike with the previous ones, we have here that my x is in the denominator. So I'm going to work through this and then I'll tell you the shortcut. So like we've been doing, I can multiply by that denominator to the other side. So here I can multiply that x to both sides. And I'm going to get x times that tangent of 72 degrees is equal to 25. Now the issue here is we haven't isolated that variable. And so here to separate those two, since there is multiplication, I can divide that tangent function on both sides. And I'll be left with x on my left side. So here, my x is going to be equal to that 25 divided by tangent of 72 degrees. Sorry, it wasn't letting me write. And so this right here will be your final answer for your calculator ready form, ready for you to plug in. Now, like I said, I'm going to mention the real quick trick. And for the next one that I do that's similar to this, I'll use that. But here you'll notice that all I ended up doing really is switching that denominator when that was my x with the trig function. Okay, so my trig, my tangent of 72 degrees became my x, which was in the denominator, and my denominator now became that tangent of 72 degrees. All right, let's move on to number 5. I'm going to start off by marking my angle, which is going to be that theta, obviously what I'm looking for. Then we have our opposite, hypotenuse, and adjacent. So looking at that here, I can see that the two sides I know something for are my opposite and my adjacent. That tells me I should be using tangent of my theta is equal to my opposite, 20, over my adjacent, 37. Okay, once again, in order to solve for your theta, you're going to use inverse tangent, your inverse trig. And so we are going to now have in parentheses that 20 over 37 is equal to theta. Once again, you do want to double check that fraction. Make sure you cannot reduce it. Here I know I can't, and so that's why that's my final answer. All right, moving into our very last problem here, we have number 6. Starting off, I'm marking my angle, labeling my opposite, hypotenuse, and adjacent. We can see here that we know our sides with the hypotenuse and the adjacent. And so that's going to leave me with my cosine. And we'll have 43 degrees is equal to my adjacent, 36, over my hypotenuse, x. Okay, once again, using that trig real quick, I'm going to just switch my trig with my denominator. Okay, so my trig function is now replaced with that x is equal. And so we'll have 36 divided by that cosine of 43 degrees. Okay, once again, hopefully this video was helpful. Remember, if you're not in my class, we leave ours in calculator ready form since they don't get a calculator. But at this point, you would then just type it into your calculator, hit enter, and it will give you your answer. And you'll follow that last step of rounding as necessary where they're instructing.